Change Detection of Lynn Valley, Kansas by Haley Timmons. For this project, we are going to be using the NV software to do a change detection analysis. Change detection has a broad range of methods, including different programs and softwares that are available to use, but for this one, we are using the NV software. Change detection is defined as the process of identifying differences in the state of an object or phenomenon by observing it at different times. Study site and data. Our study site is Lynn Valley, Kansas. If you look at the photograph on the left, you can tell Lynn Valley, Kansas is actually right on the border of Missouri. This is a small town of less than about 900 people and is actually a gated lake community. It's about a 40-minute drive south of Overland Park, Kansas. All of our data for US was attained by USGS Earth Explorer. Change detection we are doing is of an image from 2015 to 2020 to see what the difference is in that 5-year period. Study site and data. The first photo we'll be using is from July 13, 2015. You can tell there is plenty of vegetation. You can even see some of the bodies of water in the area. And then our second image is July 26, 2020. Unfortunately, I did not know there was that much cloud cover. It did not look like that when I went to download it. And that was also one of the clearest photos from that time period. So that's why I went ahead and chose to use that for my change detection. So before we can do a change detection, you must first classify the data. I use the ISO data classification, which is an unsupervised classification. So this is our July 2015 image after being classified, and then those exact same classes classified our 2020 image. And as you can tell, there is a drastic difference between these two images. You're actually able to, I feel like, see some more of the waterways better on the 2020 image, which could mean there was a lack of vegetation in that area compared to the 2015 image. Methods. We are using the NV Classic 5.5.3 and then we are running their change detection. Again, we are using the ISO data classification and it is an unsupervised classification. And then we use that data to run the change detection statistic. So understanding the results. If you look at the box over on your right, at the top it says initial state. And then on the left hand side it says final state. And initial state is our 2015 image, and then our final state is our 2020 image. And then down at the towards the bottom of the box it says class changes, and those are the number of pixels that change between the 2015 and 2020 image. Results and discussion. The results of the change detection statistics was surprising. I knew there had been a lot of change in the area, but I didn't realize like how much had changed over time. I have family that lived there, and I visit there quite often, so I didn't really realize how big of a change had occurred over the 5-year period. Like I do some smaller changes, but I didn't realize it had been quite so drastic. It was very interesting to see the amount of vegetation and architectural change that the pixels changed, like on the previous slide, that change class changes. That's what it represents. It's the amount of vegetation and agricultural change that occurred. And it was very interesting to see how much it changed. I also learned a great deal of information because of the research needed to complete a change detection. And I learned a lot of information like on the history of change detection and even how it came about. So all that was actually very interesting. References. Thank you. I hope you enjoyed.